All right, this is Susan Poss again. We are moving on with finding out particular pieces of information about parabolas, a second degree graph, or second degree function. This is the video from 10.5 and this is the 7th video. So we're sort of analyzing the function. First, in the previous one, we found the coordinates of the vertex using a formula. This time we want to find the x-intercepts of the parabola. Those are also known as the zeros of the function. Those of you who have a graphing calculator, there's a function in your menu that allows you, your calculate menu, that allows you to figure out the zeros of a function. So there are three things that can occur when you're working with a parabola, and I've sketched them out here on the right-hand side of the screen. You will either find that you get two x-intercepts. You can see that from the first example, or two zeros. The second thing that can happen is that the parabola will touch and immediately turn around at one point, so we only end up with one zero. And the last thing that can occur is that the parabola doesn't cross the x-axis at all, so we end up with no zeros. Well, no real zeros. Let me say it that way. That's better. So you'll get no x-intercepts. We will get solutions to the equation, to the function. They will be complex solutions, which do not graph on this grid, because this is a grid where we graph real values, not complex values. All right, so let's fill in some of these blanks. The zeros of a quadratic function, they are the points where the parabola crosses the x-axis. If any are the, I don't know what that wants, I'm going to say intercepts. This is where y equals 0, and you can see that from my sketches out there on the right. All of those y coordinates at those x-intercepts are 0. These points are also called zeros of the function. If the solutions are non-real complex numbers, then the graph does not cross the x-axis. And you see that from my last drawing over there in the margins. All right, so we figured out how to find the vertex in the previous video using that formula. How can we find the zeros, or the x-intercepts, of the function? We've got lots of other assignments here. We're also tasked with finding the vertex, the axis of symmetry, the domain, the range, and the graph. So I'm going to start with finding the zeros. Okay, so finding zeros, we're looking for x-intercepts. We notice that on x-intercepts, all the y coordinates are zeros. So I'm simply going to take this quadratic function here and replace y with 0. All right, so we have several ways to go about solving this. We have something called factoring, which I think you can see by just glancing at this. There isn't going to be any way we can work with that 1 out there on the end and get a -6 in the middle. Another technique we can use is completing the square, which we talked about. The square root method doesn't really lend itself here, but completing the square would. Another thing that we could do is use the quadratic formula. So I think that's what I'll do. Let me write it down. So you have several options. Every semester I have somebody who likes completing the square. better and somebody else who likes the formula, the quadratic formula better. So it's really up to you. And of course, I didn't identify A, B, and C overtly for you to see it, but I'm hoping you remember where these values are coming from. B is -6, C is +1, and A is +1. And simplifying this, 32 is 16 times 2. And I hope you notice that those numbers all possess a common 2. So I'm going to go ahead and reduce this down. So there are my two x-intercepts. There's one at 3 plus, and there is another at 3 minus. And we'll calculate some decimal values. So these are called the zeros. All right, the second thing I need to find is the vertex. So there's my formula. And B is -6, and A is 1. So it looks like the x-coordinate of the vertex is 3. And to find the y-coordinate, we just simply go into the original function and plug in, do the arithmetic. Looks like that's going to be -8. So let me go ahead and write that up here. 3, -8 for the vertex. And let me go out here and go ahead and plot it. 1, 2, 3, 4, 5, 6, 7, 8. So there's 3, -8. We already know that the axis of symmetry runs right through that vertex, and the equation for this line is x equals 3. All right, so let me check my list. I've got my zeros, I've got my axis of symmetry, I've got my vertex, and let's go ahead and graph it because that will help me find the domain and range. So we need a second point, and remember I told you in some previous video a while back that when I'm looking for another point, I like to go somewhere close to the axis of symmetry and choose an x value. So I think I'll choose 4. And you just plug that in to the original function. Sorry, I'm running out of space. I'll correct that on the next one. And I think that's -7. Let me look at that. -23. Yep, -7. All right, so if I have x is 4, then I have a y equals -7. So let me go out 4 and down 7. And remember, these things are symmetric, so there's also a point on the other side of the axis of symmetry. And hang on, let me get my x-intercepts got to go right back here, and I'm grabbing my calculator. Sorry, I didn't have that ready. So I'm typing in 3 plus 2 times the square root of 2. And I'm going to get a decimal approximation for that. And I'm coming up with about 5.8. Approximately. And let me type the other one, and the other one has a minus in there. And for that one, I'm coming up with about 0.2. All right, so 0.2 is right about there. And 5.835 point, whoops, needs to be a little further over, doesn't it? Is right about there. So remember, those are x-intercepts, which means the y-coordinate of the point is a 0 value. All right, so I'm going to come back in here and try to graph this. It's kind of hard for me to hit all these points on this slick screen. There. So the parabola looks something like that. So our analysis has told us a lot of pieces of information. I have the coordinates of the minimum point, which is the vertex here. I've got the x-intercepts, which are the points where the parabola crosses the x-axis. I've got the axis of symmetry, and now I need to get, and I've got the graph, so now I need to get the domain and the range. All right, so on these, the domain on these parabolas that open up is always all real numbers. The range, however, is something that is going to be just where the picture occurs, and the lowest point, the minimum point on this, remember range is always in terms of y values. The lowest point I see here is down here at right there. That lowest y value is a y value of -8. And from there, that's where the lowest point on the parabola is, and then it takes up y values that go all the way out the top of the screen. So the range here is going to be inclusive of the -8, and it's going to go all the way out to positive infinity as it moves out the top of the grid. So I hope that helps you. I'm going to stop for a minute and go create some more space before I do another one of these, because I've sort of got it all jumbled up here and I don't like that. So I'll try another one in just a minute.